afternoon, everyone. I'm Kelly Oskvig. I'm a Senior Program Officer with the Division of Earth and Life Studies at the National Academies of Sciences, Engineering, and Medicine. So thank you for joining us for a webinar on the report that we were thrilled to release this morning, titled Forecasting the Ocean, the 2025 to 2035 Decade of Ocean Science. You can now download a copy of the report and other supporting materials at nap.edu. A recording of this webinar will be available on our website in the coming weeks. For those of you not familiar with the U.S. National Academies, we are private, nonprofit institutions that provide independent, objective analysis and advice to the U.S. to solve complex problems and inform public policy decisions related to science, technology, and medicine. For each study requested, committee members are chosen for their expertise and experience, and they serve pro bono to carry out the study's statement of task. The reports that result from the study represent the consensus view of the full committee, and they must undergo external peer review before they're released, as did this report. I have the committee co-chairs and a few members of the committee that wrote the report here with me today. Before they begin, I want to go over just a few reminders. The first one is, please note that this webinar is scheduled to last 1 hour. We'll start off with a presentation that summarizes the report by the committee members. This will last roughly 40 minutes, and then we'll open it up to any questions you may have. To ask questions, please use the Slido link displayed on the screen and post it in the chat. You can submit a question or upvote a question at any time during the presentation. If we don't have time to answer your question, or if other questions arise after you've actually had time to read the report, please send me an email and we'll respond to you as soon as we can. My contact information is included on the last slide, and I'll also share it in the chat. And with that, I won't waste any more time. I'll turn it over to Tuba Oskan-Haller, Dean and Professor at Oregon State University, College of Earth, Ocean, and Atmospheric Sciences, and co-chair of the report's authoring committee. The floor is yours, Tuba.
Excellent. Thank you, Kelly. Welcome, everybody. An exciting day when we are releasing our report entitled Forecasting the Ocean, the 2025-2035 Decade of Ocean Sciences. This report is the result of a statement of task that asked the committee to carry out a decadal survey. Other fields have carried out decadal surveys for quite some time, but for the ocean sciences, this is only the second such effort. This type of decadal look has the potential to help us reassess the importance of investing in research related to the topic at hand, in this case, the ocean. And it is an opportunity for the research and development community to focus on what can and should be accomplished in the next decade. And we hope that our report will galvanize just such progress, both on the part of federal local agencies, but also on the part of the scientific community. So as we began our work, we also took a step back and spent some time making sure that we clearly communicated why R&D in ocean sciences is so important. We did not want to skip this very important step. So in our first chapter, we highlighted some of the reasons why we believe there's an urgent and vital need to invest in our ocean research, ocean infrastructure, ocean workforce. And these reasons can be grouped around 3 themes. The first one being national security and international leadership. The second one relating to strong economies and the vibrant communities that they serve. And the third one being health and well-being. With this audience, I will not spend time going through a lengthy process of talking through these with you. But what I will say is that our report strongly argues that today, the U.S. ocean science enterprise is at a crossroads, and that U.S. leadership in ocean sciences is in jeopardy. With the recent cessation of support for the U.S.'s only scientific drilling ship, the U.S. scientific community has lost access to most of the global ocean bottom. And this is challenging the multi-decadal U.S. leadership in this field. The rest of the academic research fleet is also aging. Meanwhile, other countries, such as China, are investing heavily in ocean science infrastructure, particularly as it relates to deep sea exploration. So in combination, these events leave the US without the infrastructure needed to support the research. And it is clear to us that US leadership in ocean science, technology, and engineering is at stake. So now is the time to invest to save US scientific leadership. And the investments made will not only restore US leadership and bolster national security, but they will also benefit strong economies fueled by vibrant communities, as well as topics around health and well-being. And our report outlines a framework to accomplish this. Our report is comprised of 5 chapters, and I will very quickly walk you through the first 3, and then I will hand it to my co-chair, Jim Yoder, who will pick things up from there, talk through the latter 2 chapters, and bring things across the finish line. So let's start with our study context. As I mentioned, this is the second decadal survey of the ocean sciences. The first survey was released 10 years ago. Their statement of task was very much focused and asked for input on the balance of investments in infrastructure versus funds that would be available for basic research functions. And as part of their survey, they identified 8 research priorities, and here they are listed again, starting with topics that pertain to the top of the water column all the way down to the seafloor. Our statement of task was quite different. First, we were asked to produce an interim report that pertained to the subfield of scientific ocean drilling, and that report was released about a year ago. Our statement of task for the full report is summarized here. It called for us to look at novel opportunities around use-inspired, solutions-oriented research. It challenged us to think about innovative, multidisciplinary, multi-sectoral approaches, because that's what we need to do in order to address complex science challenges. Importantly, our statement of task asked us to come up with a portfolio of high priority scientific questions. And the committee took this part of our statement of task really seriously and did the hard work of focusing on a few high priority questions. And then we were asked to think about the research infrastructure needed in order to make progress on these priorities, as well as how NSF could leverage and complement its relationship with its partners. Okay, so the committee was comprised of 23 highly dedicated, highly engaged individuals from various sectors, including academia, private foundations, industry, nonprofits, government agencies. These were some amazing folks to work with, and I thank them here formally for all of the work that they have put in. Our process followed the consensus study process that the National Academy has pretty closely. We had various hybrid meetings. We had many information gathering sessions, more than 100 experts presented. We deliberated in closed session. We reviewed all of the relevant reports that we could get our hands on. We had both virtual and in-person town halls. Like I said, our interim report was released a year ago, and our full report went through an extensive review process by an additional 15 experts, some of whom may be here in the audience. And I really want to thank these reviewers for the thorough work that they did. And I can tell you that the report was significantly improved because of the work that they have put in. So thank you. So as a result of our deliberations, we arrived at various conclusions that are all in the report, as well as 11 explicit recommendations. And these all fit within a framework with a few attributes that I just want to go through, high-level attributes. First, we were clear that funding for basic research must continue. NSF was tasked from its founding to be the one government agency that will fund basic research. And clearly, this was in recognition of the fact that basic research produces the raw materials in the assembly line that is geared towards technological advances. So basic ocean science research has certainly produced such benefits in the past, benefits that have saved lives, property, restored economic viability, and this must continue. Basic research must be nurtured in order to continue to do so in the future. Second, the committee felt strongly that we should articulate a challenge for ocean science research over the next decade, a challenge that can serve as a focus for the next decade. Third, because our statement of task explicitly challenged us to do so, the committee worked really hard in addition to identify just a few high priority scientific questions that would benefit from basic research and that would yield immediate societal benefits, so questions that are use inspired. We took this ask very seriously and we worked hard to arrive just at a few priorities and frame them in a way that provide focus while also keeping the topics broad enough to allow everyone to continue to contribute to progress. And then finally, note that in contrast to the first decadal survey, our committee was not asked for advice on balancing investments across infrastructure and research. We were also not asked to comment on how specifically NSF should go about following our recommendations. So please keep that in mind. Okay, so here are the pieces of the framework and how they fit in. The challenge for the next decade, depicted here at the top, is meant to provide motivation, a means to prioritize, a way for everyone to bring their talents to a common purpose. Now, NSF's commitment to basic research is at the foundation of all of this work, right? So in addition to basic PI-driven research, a broad portfolio thereof, the research priorities that we have identified connect some of that basic research to the challenge of the decade up top. And then the supporting infrastructure and some ideas around expanding opportunities make possible progress. So we're going to dive into all of these components here. Our first and perhaps most important recommendation to NSF is that NSF must continue to support a broad portfolio of basic research so that the scientists and engineers of the future have access to a continually improved understanding of the ocean, because that's what will advance and fuel innovation and resilience in the US. The importance of this recommendation cannot be overstated. Basic research must continue in the next decade and beyond. For the next decade, however, we believe that posing ourselves a significant challenge will help focus and fuel our efforts, and the committee articulated this challenge as follows. We challenge ourselves by 2035 to establish a new paradigm for forecasting ocean processes at scales that are relevant to human well-being. The committee elevates the ability to forecast as its challenge to emphasize the importance of developing testable hypotheses for future conditions. And we've put together this figure to try to kind of display to you what we mean, what the steps are that would be leading to such forecasts, and including the step of posing basic science questions and then carrying out the observations or modeling required to get to an answer, and then putting this improved understanding to the test right away through incorporation into forecasting tools. So any improvements in those forecasting tools will then serve the task of telling the story to the world of the importance and utility of the basic research that led to that improvement. And on the other hand, any shortcomings in the forecasts will help us hone in on what we need to study next. So this creates a positive feedback loop. Of course, forecasts are also key to addressing use-inspired issues beyond basic research and for identifying, prioritizing efforts that are needed to respond to changes in the Earth system. And while forecasting is elevated here, all of the steps in this continuum are clearly essential. Now, you might say operational forecasts are not in NSF's purview, and that is true. So translating basic research into forecasts that are operational requires partnerships with other mission agencies that are focused on ocean science. And we'll talk about those expanded opportunities here in a little bit. You might also wonder what we mean when we say scales relevant to humans. For some challenges, for example, for some extreme events, society might be best served with forecasting timescales of days or weeks. Others, such as sea level rise, for example, might require longer timescales. Similarly, decisions on, say, fishery management or ecosystem services or renewable energy considerations potentially contain multiple decision time and space scales. So no single forecasting system can be constructed that can be helpful in all of these cases. In other words, forecasting the state of the ocean at scales relevant to human life must occur at various temporal and spatial scales, as dictated by the societal question at hand and by the nature of the ocean system processes that we're studying. I will add that research is, of course, also needed on the limits of predictability of the ocean system. And so these limitations may be due to lack of detailed knowledge of the state of the system, or they can be inherent complexities in the system that may lead to chaotic behavior. So some ocean processes might be difficult, if not impossible, to predict with any accuracy. And so these complexities might then necessitate the development of probabilistic approaches to eventually serve as components of a forecasting system. So I want to emphasize that establishing this paradigm will require a relentless focus on furthering basic science to observe, understand ocean processes through the lens of both innovative disciplinary research practices as well as transdisciplinary research practices. So back to the challenge. The challenge actually also includes a little bit of verbiage on what the interconnected themes might be that we should be focusing on. So I will tell you more about these themes and the related research questions next. But before I do, I want to walk you through very quickly through how we evaluated what themes to include in our study. We used an evaluation matrix that really looked at 4 specific questions. One was around whether or not the investment was appropriate for NSF and for the Division of Ocean Science for the unique responsibilities they have. And so we asked ourselves questions like, does the research fall inside the bounds of the NSF research realm? We talked about the importance of a particular topic, if it was compelling or timely. We thought about the impact of a theme. Would the research impact be to a wider scientific community? And then finally, we thought about the potential of a particular theme to be advanced by transdisciplinary approaches. And we'll be talking more about that here in a minute. So for each of the 3 themes, we also articulated a central research question. And here are the themes. First, ocean and climate. Second, ecosystem resilience. Third, extreme events. I want to talk through really quickly each of these topics. The ocean and climate theme, the central research question we articulated is, how will the ocean's ability to absorb heat and carbon change? And here we have listed some example research directions. I'll just pick on one: obtaining better observations of surface PCO2 in the Southern Ocean in the winter to constrain ocean CO2 uptake, for example. And I am sure you can think of other research questions that you can pose within your subdisciplines that will help with this overarching question of the ocean's ability to absorb heat and carbon. Now, are there US-inspired cases that motivate us to study in this area? Absolutely. And perhaps, most easily connected are issues around marine carbon dioxide removal or modeling the Earth's system, especially as it pertains to tipping points in the major components of the Earth's system. And then we also in our report articulated potential outcomes of the work of the basic research in this theme. And here they are. The second topic, ecosystem resilience. Here our central question is, how will marine ecosystems respond to changes in the Earth's system? And here again are some examples of research directions that one could pursue under this theme, including things like predictions around the biological pump export production, how this will affect trophic structure and function, for example. And again, you all can probably immediately see how your work could fit under this particular umbrella. The use-inspired cases here are, of course, related to fisheries. they're related to understanding ecosystems, or deep sea mining is also an important piece here. The third topic, potential outcomes, of course, not to be neglected. Here, of course, development, intervention of strategies for restoration of ecosystems, for example. And then finally, last but not least, extreme events. And here, the question we've posed relates to how the ability to forecast extreme events, those that are driven by ocean and seafloor processes, how that ability can be improved. And here are some potential research directions that one could pursue under this theme, including producing extreme event forecasts to inform, say, new societal adaptation and ecosystem restoration approaches, for example. And the use-inspired piece here, I think, is pretty clear. Coastal resilience, sustainable agriculture, decisions around infrastructure investment are some examples. And potential outcomes, I think, in this theme are also pretty easily expressed. Sustainable fisheries being one, sustainable agriculture being another. Okay, I want to very quickly touch on expanding opportunities and how expanding opportunities can help us with these, as well as a broad portfolio of basic research ideas. And here, here we want to talk about three things. We want to talk about the importance of transdisciplinary research. We want to think about what this means for workforce development. And thirdly, we want to talk about strategic partnerships, expanding strategic partnerships. Okay, first, we have a recommendation where we strongly argue that we need to do the work we're doing through a transdisciplinary lens. And what this means is that really we need to think about enabling research that crosses directorates and programs. So this is not to say that we won't do discipline-based work. In fact, we must. But we argue that even with the disciplinary work, we must do this. It must happen in a way through a transdisciplinary lens, thinking about how the results will connect to work of other disciplines from the get-go. Okay, next recommendation pertains to workforce development, and it really has two pieces to it. One is as it relates to reskilling and upskilling the existing ocean science workforce, including the academic workforce, as well as other parts of the workforce. And we want to make sure that the academic workforce specifically, perhaps even, it knows how to engage with industry, entrepreneurs, interest holders, and other partners in ways that perhaps we have not done as much in the past. And then the second part of this recommendation pertains to developing a new, fostering incoming folks in the workforce and making sure that we can provide them a safe working environment. And then the third piece about expanding opportunities relates to strategic partnerships, the road less traveled, right? We acknowledge, as a committee, we acknowledge that it is difficult to expand partnerships, to sustain them with other directorates, with other mission agencies, industry, other organizations, nationally as well as internationally. We acknowledge that this is a very difficult task. But we also think that this is very, very important in order to move the work that we have outlined here forward. It is essential for the particular challenge that we have posed for ourselves for the next decade. Okay, with that, I'll hand it over to my wonderful co-chair, Jim Yoder.
Hey, thank you, Tuba. And I'm going to talk about infrastructure and facilities. The committee examined how the core infrastructure could support the research just described, as well as looked at the role of new and emerging technologies. Facilities and infrastructure costs are rising rapidly, and the three most expensive facilities, which are the academic research fleet, the Ocean Observatories Initiative, and scientific ocean drilling, now account for about 50% or more of OCE's core budget. I'm going to first talk about the academic research fleet and deep submergence. Oceanographic ships are the workhorse and the backbone of oceanographic measurements. At present, we have the right size fleet given the current budget levels. However, we need to replace existing capabilities as ships age. The good news is that there are 3 new NSF-funded regional class vessels which are coming online before the end of the decade to replace the intermediate class vessels, Oceanus, Endeavor, and Wacoma. However, there are no current plans yet to replace the Navy-owned global class vessels, which are Atlantis, Thompson, Revell, and the ocean class Kilo Moana, with end of life in the late 2030s to early 2040s or earlier. This seems like a long way off, but it takes a long time to plan and build new ships. Also, the 2 Navy-owned ocean class vessels, Armstrong and Ride, will need midlife refits in the mid-2040s. These larger ocean and global class vessels are critical to ocean science. More than half of the scientists' days at sea are on these vessels. They are capable of carrying and deploying large current meter arrays, sediment traps, and other large equipment, including the research submarine Alvin. They have the capability to work at sea for extended periods of time and in more severe weather than can smaller vessels. Ships also serve as platforms for launching autonomous vehicles, which can expand the footprint to make ship sampling more effective. I want to point out also that there are no plans yet to replace the local class vessels that are owned by state governments, although used by NSF-funded investigators, and some are getting quite old. Finally, the Langseth, the only vessel in the fleet with active seismic capabilities, needs replacement in the very near future. The report recommends a number of enhancements to the deep submergent facility, including to expand the array of assets available to users, including remotely operated vehicles and autonomous underwater vehicles for deployment on coastal and regional vessels. The final point on the academic fleet is, do we have the correct balance of ship capability for the future? The committee recommends an evaluation of future ship needs looking beyond the end of the coming decade. I'll talk about the Ocean Observatories Initiative next. Several components of the current OOI will contribute to the science themes we identified. With respect to the hazard science question, data from the cabled array off Northwest U.S. has significantly contributed to understanding the seafloor geological processes associated with plate movements. For the carbon and climate question, the open ocean arrays are particularly important for determining air-sea fluxes of heat, momentum, and gases. A little background. The OOI concept dates back to the late 1990s and is managed and operated now by research organizations. Management of OOI has been well reviewed, and the operators are doing an excellent job. However, it was difficult for the committee to assess OOI's scientific contributions, so the committee recommends that NSF evaluate those contributions. In other words, given its high operating costs, what unique contributions has OOI made to understanding ocean processes? One approach is for NSF to conduct a revisioning and restructuring exercise for the future of OOI. This would include an evaluation of the scientific contributions of OOI, reconsideration of the goals and objectives of the program to align with those of the ocean science research community, and consideration of new technologies that may not have existed when the program was first designed and envisioned. And next, I'll talk about ocean drilling. The committee did release an interim report which included many conclusions related to the future of scientific ocean drilling, but no recommendations. We were not asked to put recommendations in that report. As background, the U.S. developed scientific ocean drilling technology and capability in the 1960s and sustained global leadership in this field until 2024 when the JOIDES resolution was retired. ODP, the Ocean Drilling Program, was the precursor to IODP, and ODP, which ended in the early 2000s, was focused on only one drill ship. It had primary funding from the NSF, from the Division of Ocean Sciences, but also funding from Japan and from a European consortium. IODP, when it was started in early 2000s, involved it involved the JOIDES resolution, but Japan wanted its own drill ship, and the European consortium wanted its own platform as well. That left NSF carrying the full cost of operating the JOIDES resolution. It was able to do so for a couple of decades, but finally the cost of operating that ship exceeded the available budget, and NSF was forced to retire it. With the JR retirement, U.S. has yielded ocean drilling leadership to China, which is now the only country that will be routinely collecting cores in the global ocean with its new drill ships. The committee would like to see OCE develop a financially sustainable ocean drilling program with a full-time U.S.-based drill ship. That might be possible with a different management and operational model, including developing and nurturing more options for industry work and possibly involving reliable international partners. However, without a dedicated drill ship, OCE can still operate mission-specific platforms for high-priority drilling targets. The committee also believes it is important to fully analyze existing cores with dedicated funding for a program to do that. There's also the need to evaluate the potential for seafloor drilling technologies. Existing commercial seafloor drilling equipment is very heavy, and the community was told that no vessel in the UNOLS fleet can deploy such equipment. Are there options? A few other comments on infrastructure and facilities. Autonomy is increasingly important, with AUVs capable of many routine measurements to operate independently or to augment ship measurements during expeditions. The Argo float array is a great example of independent robotic sampling, providing the only global observing system. OCE needs to continue to do its share to support this international observing system. OCE needs to consider future options like shared instrument pools, for PIs to acquire and use autonomous platforms during expeditions. Apologize for my voice when I'm getting over a bad cold, so let me get a drink of water. A smaller OCE supported facility provides geophysical instrumentation pools which support important facilities supporting the research of geological hazards, for example, which include underwater earthquakes and volcanoes. Our reports also mention some other new and underutilized technologies that can enhance ocean sciences access to the sea using new or underutilized technologies. Some examples are, for ocean chemistry, there's a need to measure partial pressure of carbon dioxide at sea. For biological measurements, environmental and organismal DNA, biosensors for species abundance. And there are new possibilities for instruments to measure seafloor geodesy applications. Also, new possibilities for the applications of acoustics, for example, distributed acoustic sensing, and smart cables, which carry standard commercial communications traffic, but also have regular portals for accommodating instrument packages on the seafloor. Smart cables are now being used in Europe in some places, and I don't believe they're yet used in the United States, but they're a potential for putting instruments on the seafloor and getting the data back in real time. Finally, we need new avenues for bringing novel sensors to market at scale and broadening access to the larger research community, perhaps with an instrument pool approach. Many of the new and sophisticated instruments are quite expensive, making it very difficult for PIs to acquire them on individual grants. So a pool approach may make them more available for scientific research. Finally, the committee recognizes the importance of cyber infrastructure, including artificial intelligence, specifically improvements in all areas of cyber infrastructure and cyber-related applications, including data curation, uncertainty quantification, AI, numerical modeling, fair and care principles, cybersecurity at sea and on land, and other aspects are essential components of successfully addressing all three of the science questions highlighted in this report, as well as other research. Our committee felt we did not have the expertise to do justice to this topic, so we recommend that OCE convene a workshop or other activity that would seek expert advice, review established strategies, and develop peer-reviewed guidelines and practices for ocean science data, curation, computing, and security, both on research vessels and on shore. So I'd like to move on to what amounts to the final chapter in our report. Well, first of all, we do have a table in our report that sort of summarizes how we see the various infrastructures aligned with our science questions. Anyway, in Chapter 5, we have something we call the Pyramid of Hope. And I'd like to just go through it very quickly. The base of that pyramid, you notice there's the NSF commitment to basic research, and that's our first recommendation. And really, it's the way NSF works, and it works on a peer review system. You have an idea, you submit a proposal, it's well reviewed by your peers, you can perhaps expect some funding. We also believe it's important to expand opportunities through workforce development, new partnerships, and transdisciplinary research approaches. We also think that it's not, with respect to expanding opportunities, it's not just workforce, but we want to expand the understanding of the importance of the ocean beyond coastal states, where it is generally recognized, but less so in the interior of the country. But it's important to try to engage people in the interior of the country because ocean processes affect their lives as well. Also, we need to keep up to date on infrastructure, and OCE, I know, tries to do that. That's right. That has to do with recommendations 6, 7, 8, 9, and 10. And there are 3 science questions, science themes, and that's recommendation 2. And finally, we'd like to move from understanding of processes to forecasting ocean processes at scales relevant to human well-being. So we call it the Pyramid of Hope because we hope that that's what we will end up with as this new decade starts. Finally, there is a goal of trying to regain leadership in the ocean sciences. We have the people, ideas, technologies, and the desire. We need the resources. And I think I'm going to turn it back to Tuba just in time here as my voice crafts out, and she has some closing comments.
Thank you so much. Thank you, Jim. So please have a look at the report and read it carefully and get all the way to the end, because at the end, our report does end with a call to action. We plead with you, the ocean science community, to connect your work to the framework that we have built in this report. The priorities we have identified may not be the ones that any one of you individuals may have chosen. They may not even be the priorities any one of us as individuals might have chosen independently. But the committee did the hard work of building consensus and agreeing to focus. And I hope the ocean science research community will be willing to do the same. So we ask you to come together around the ideas in this report so we can collectively show the world that what we know to be true at the gut level, that our work is important, that it's vital, urgent, and that we explicitly contribute to our societies. So we ask you to bring your talents and skills to the specific questions outlined here. We ask you to innovate, to collaborate, to push the boundaries of knowledge. And in that way, the report can serve as a glue, as a handshake to help us collectively move the needle and show the world the importance of this work. We need all hands on deck. Thank you.
Jim. We have plenty of time for questions. Before we get to that, I just want to draw your eye to all the names here on the screen. These are volunteers that have shared their expertise with us throughout the process and also reviewed our work. So a big thank you to all these folks and others, I'm sure, that have really helped the committee focus on these 3 priorities and our themes, and we couldn't have done it without all of you. So thank you very much. So I'll leave this slide up for just a little bit, just because it has the Slido QR code. and the link to our report. It sounds like a lot of people are downloading the report so much that the system maybe can't take it right now, but be patient with us. Okay, so we have 20 minutes left for questions. That's fantastic. I see a whole lot coming in through the Slido. Thank you all. So I'll just start with the most popular right now. So this one says, I applaud the aim to collaborate with other NSF directorates. Which other directorates and/or programs did the committee identify as the best ones right out of the gate, with the caveat that the agency is under siege at present?
Thank you for that question. So some of the directorates and programs at NSF that we did talk about were, of course, the TIP directorate. You know, what does it look like to really engage with that innovation space? And here we talked a lot about things like instrument development and what that might look like, but the recommendation regarding upskilling of the existing academic force really came from those conversations, because we as academics need to get better at talking across those those boundaries where people are motivated by different desires. Engineering is, of course, another one. We talked about social and behavioral sciences. We also talked a lot about other agencies outside of NSF, including mission agencies such as NOAA or Department of Energy. Certainly more interactions with stakeholders, with philanthropic opportunities, as well as a renewed effort to really engage internationally in the space is certainly something we talked about. Jim, is there anything else that you want to add to that?
No, I would suggest maybe Jason might have a comment from the NOAA perspective.
Thanks, Jim. Yeah, the perspective of the committee was not just NOAA, but it was all kinds of ocean sciences. And there's a complementarity, as the title implied, and as Tuba was getting at, with the forecasting element that I think could really go hand in glove. So I would certainly point to that. I would also point to just the research, the basic research that NSF does can then often be handed off to some of the more operational agencies like USGS, like Department of Interior, Army Corps of Engineers, NOAA, et cetera. So there's a lot of potential elements that could be brought together. And I think the ocean science community writ large would be benefiting from a lot of the things that we tried to pull together. Thanks, Jim.
If I can add to this,
thank you.
Too, I think we also think that there's a lot of value and importance in reaching out to the humanities, social sciences, as well as economic disciplines, and the report speaks to that quite a bit in the section on transdisciplinarity. And those are other ways that we can make connections with other agencies and directorates and produce some really meaningful results for the scientific community.
Thank you, everyone. The next question is, when the slides on fleet replacements came up, I wondered if the need for a new JR-style drill ship was discussed too. Perhaps Rick or Jim?
Yeah, Rick, if you're on, maybe you want to take that.
Yeah, sure. So first of all, just as a gentle reminder, remember the drill ship is not part of the academic research fleet. It is a completely different facility. So yes, it was indeed considered separately. I draw your attention to our interim report, which was referred to in this presentation today, that was published fully late last fall, 2024. And in this report, particularly on pages 91 to 92, up to 95, 96, we have in-depth discussion of scientific ocean drilling, and in particular recommendation 4.3, which specifically does make reference to a US-based drill ship in the context of fulfilling scientific objectives, as well as Tuba was pointing out near the end, reacquiring US international leadership. We also made specific recommendations to the National Science Foundation regarding activities they should consider supporting in the interim time period while a new drill ship is being formulated and ideally brought to fruition. Thank you.
Thank you, Rick. And the next most popular one is also on the drill ship, and they're asking if any other platform has been as successful at accomplishing missions as the JR.
Well,
go ahead. Go ahead.
Yeah, I'll just jump in.
Yeah.
That depends a lot on what one defines as successful. There are other platforms that can achieve certain scientific objectives by scientific ocean drilling. Mission-specific platforms from other countries have been doing that. There are seabed-based lander drilling type things, and these are all discussed in the different reports. However, a drill ship is required to meet the vast majority of objectives because the drill ship can drill in deep water, it can do deep penetration, and it can also outfit and drill holes for borehole observatories and other adjacent supporting infrastructure to achieve the scientific objectives. So yes, certain objectives can be achieved by other developing novel technologies, but only a fraction of what can be achieved overall regarding the three scientific themes that we emphasized.
Thank you, Rick. This next one I think would be for maybe Lahini or Brad. The NCAR is a key component of infrastructure and ocean modeling and analysis of climate model simulations to understand the role of the ocean in climate change and prediction. Is there a discussion in the infrastructure section for modeling?
Thank you for that question. I think we have emphasized the importance of modeling actually throughout the report. And I think we also discussed the importance of computing resources to support that and the importance of collecting data on the time scales, on the temporal and spatial scales that are relevant for actually forecasting change. So I would say just generally speaking, we emphasize modeling throughout, the importance of modeling throughout the report.
Yeah, now just
go ahead, Brad. Go ahead, Brad.
Yeah, so yeah, just to follow on from that, yeah, it's really about seeing modeling integrated into both the thinking, the forecasting, the observation, that whole kind of value chain description that Tuba showed. And it's really about not saying how to kind of integrate that, but that modeling needs to be more integral to all aspects of ocean activity, from observation through to kind of forecasting, and not just boxed off to the side as it sometimes can be.
Yeah, and thank you. And I'll just add to that we also talked about the importance of expanding the tools that we have. You know, the traditional modeling approaches, yes, the data assimilative approaches, yes, but also new machine learning tools and how we can really take advantage of large language models that have come online now in ways that maybe can really catapult us to the next level. So really, really important piece.
Thank you. Next question is, how can we be sure that our ocean knowledge base is sufficient to identify what research is important for human well-being? Won't broad, basic research by its nature reveal benefits to humans we cannot predict now?
Thank you. Thank you for this question. I love this question. And yes, you are absolutely correct. This is why our #1 recommendation is that basic research, PI-driven research, research by the community on any topic related to the ocean must continue. And NSF must make it a priority to continue to fund a broad portfolio of questions, exactly for the reasons that you state. Because it is that kind of research that can really lead to benefits that we didn't even anticipate, right? In addition to that, we argue that we really need to come together around certain topics in order to push those carts up the hill as fast as we can in order to show the benefit of the research that we do to society in short order, right? And so that's where the goal comes from. That's where the challenge comes from, to kind of motivate us to also, in addition, do that. So here we argue that we should be doing, it's not an either or, it's an and.
Thank you, Tuba. Did anyone else want to add on to that? Okay, next question. Ocean data collection, storage, access, and preservation has been unevenly supported by U.S. federal resources. Is there any recognition that this infrastructure is fragile and needs stronger connections with international partners?
Yes. Go ahead, Jim.
Yeah, I mean, it was in our infrastructure section, and we point out that it is extremely important, but we did not get into the details on it just because we didn't think our committee had the right people to do this. But we have a strong recommendation saying that NSF should convene a group that does have the expertise to do this, and then we have a list of the things that they might want to consider, which includes, for example, AI tools and modeling, and also data curation and so on.
Yeah, we also go ahead, Brad.
And I was just going to concatenate to your list there, Jim, and also explicitly focuses on the benefits of learning from international partners and also collaborating and coordinating with international players, because there clearly is, these are global data that we're touching, and so international partners offer lots of benefits. Sorry, Tuba.
No, great addition, Brad. Thank you. We also talked as a committee about, those of us who hail from the academic sector, how there's a lot that we can do within the academic realm to make sure that we reward people for curating their data sets and make them available in ways that are truly usable by others. If your choice is between, am I going to write my next paper, or am I going to curate my data set, our evaluation system needs to be aligned with the value that it's important that data sets be made available in ways that are truly usable. Thank you for that question.
Thank you. Next question. Did the committee consider the role of the prospective Antarctic research vessel? And if so, how did you envision it being included?
I guess we really didn't. There is a whole separate report on that. And we talked about it at times and thought about it, but we really did not get into detail on that ship, and not sure I can say much more than that.
Yeah, and go ahead, Rick.
Yeah, I would just add to that. We were aware of ARV. We discussed it primarily in the context of the anticipated real demands on infrastructure about 5 years, a decade from now, when you look at what we wrote about the need for global vessels, which take a long time to plan, midlife refits of some of the ocean class vessels, which are now relatively new, but getting to midlife in about 10 years. And you've got ARV, you've got a scientific drill ship. So there's a lot of activity coming up around large vessels, including ARV. So that was primarily the context that we discussed it. But as Jim said, there was whole separate studies about that.
Yeah, and Hannah, I think, just posted a link to that report, Future Directions in Southern Ocean and Antarctic Nearshore and Coastal Research. That report came out in the middle of our deliberations, and that was certainly one of the reports that we looked at heavily and that influenced our thinking. So I would advise that you go back to that report as well.
Thank you. Next question is, how prepared is the scientific community to conduct transdisciplinary research? Does the report comment on how NSF or other means can better prepare scientists to approach research in this way?
Yes, so this is really that upskilling piece that we talked about as far as our as part of our workforce development discussion. We felt pretty strongly that we should make available opportunities for current researchers to engage, to be really trained, or we're steeped in a certain way of doing science, and now we need to learn to do the science in a new way yet. And that's going to require time, it's going to require resources, but it feels like this is really needed in order to move our work to the next level. I think I would not be overstating it when I say that the committee saw this time and time again, where amazing new understanding is being generated, but then the handshake doesn't happen with the other discipline that could really take that to the policy realm or take that into an arena where real impact can be attained immediately. So, and the more we think about that from the get-go, the easier that handshake becomes. And Jason, you look like maybe you want to add to that.
Yeah, I echo what you said, Tuba. I would love that question. I would simply say, look at our committee and look at all the disciplines on the committee. There were some fascinating discussions that I certainly learned a lot from. And I think just as a microcosm of what we could learn and how we might be able to do it, we were modeling that. And I think there's a lot of things that you'll see in a couple of those chapters that speak to that in particular.
I'll just add also that there are specific examples we do give about of programs that have been successful, such as the extension programs, and some other actual examples of areas where this has been successful. So we urge you to look at those as well.
I can add to this too. You know, these types of ideas around transdisciplinary research, it may involve somewhat of a culture change in the way that we do science. And culture change doesn't happen overnight. It takes a lot of dedicated effort. And we do provide some examples in the report about the importance of, you know, establishing shared goals at the start of research, establishing teams with trust. And these softer elements of the transdisciplinary research are what could potentially lead to success in this area, and a lot to build on.
Thank you, Layla.
Yeah, thanks everyone. The next question, will the future ocean decade address the rights of nature approach for protecting natural capital and ecosystem services associated with key species in the ocean food web on longer timescales than decades?
Yeah, what an interesting question. That reminds me of the concept of like some companies are using where when you have a board of directors that the earth needs to have a seat at the table, right? That it needs to be there when decision making is being engaged in. So yes, the future decade addressing the rights of nature is something we've discussed. I don't know that it ended up being central to our report. Anyone else want to chime in on that?
I wouldn't say it ended up being central to the report, but in our section about ecosystem resilience, we do provide some examples of how considerations of nature are important in the forward-thinking research that we do. And the topic of ecosystem services, you know, is always an interesting one to engage in, and how we look at services from one direction of the services of nature to humans versus, you know, our impact on those services. It's certainly discussed in the report.
Yeah, and certainly Steve on our committee was quite vocal on species, the importance of species, the worry about species disappearing, and so on. So we learned a lot from him about this topic, and I think it is reflected as was said in the report.
Thank you. I think we have time for one last question. So I'm going to ask a collaboration question. Would enhanced collaboration with other NSF large facilities such as INCAR be encouraged?
Yes, certainly. Absolutely. Yes, I'm seeing a lot of folks nodding. Definitely part of the conversation, and for many reasons, including an earlier question around NCAR being an important resource.
It's on autonomous vehicles. They're probably into autonomous aircraft, and I'm sure there's some overlap with the ocean vehicles in that topic.
Thank you. Actually, before we go, there is one person that's been very patient and asking about how small island fisheries fit into the study and how digital twins could be used for conservation of species. Would anyone like to comment on that?
Island fisheries or inland fisheries?
Oh, did I read it wrong? Inland fisheries.
Right.
Oh, that's a totally different question.
Yeah, depending on whether or not that was a typo or not. But inland fisheries, so one of the things that I think we really wanted to pay attention to is how the ocean impacts not just folks living on the coast, but the ocean impacts everybody, even the furthest place away from the coast is impacted by the ocean. So that continuum approach is something that we've discussed and really wanted to emphasize. So yes. And of course, island fisheries there too is an important topic that we talked about quite a bit. And I don't know if anyone wants to add and maybe also a little bit talk about island fisheries. Yeah, maybe I'll just add that, the Pacific Islands has been a topic that we talked about at length, and there is some examples in the report specifically about that. So I encourage you to go look at those. And I know, Kelly, we're coming up on time, but can I have like 30 more seconds for some closing remarks?
Sure.
Okay.
100%.
All right, folks, first of all, we're so excited to finally be able to talk about our report. These ideas have been in our heads and we've been interacting and talking, and we really are looking for engagement from everybody, from the research community. I once read that a good goal should scare you a little and excite you a lot. And I think we really tried to pose a challenge for ourselves that did just that, scared us a little, but excited us a lot. And there is a little bit of a scariness associated with the idea that, any kind of new finding and understanding should be put to the test right away through forecasting tools. I mean, it's a little bit scary, right? But at the same time, it can also be humbling. And the idea that we can actually contribute to improvements in forecasts right away, I feel like now that's exciting. And the idea that our society will appreciate, applaud, encourage, celebrate the work that we do is also super exciting, also a little bit scary. So we're really hoping that we have found that right balance and that you all will come on board. We do need all hands on deck. And thank you to so many of you who are here today.
Yes, thank you all. We are out of time. Once you exit the webinar, you'll be redirected to our report page. And with that, I just want to thank all of our speakers and Jim and Tuba for giving us such a great overview, all the great questions, all the great answers. And thank you all again for coming today.